Hello Ace, this is RetroTK2 and today we're looking at interfaces in C#. If this is your first C# video, I'd strongly suggest watching the videos from the start. Cards should be on your screen to the series now. And if you haven't already, might I suggest downloading the channel files that accompany this video. Cards should be on your screen once again. So let's get started. What are interfaces? Well, according to the Microsoft Docs, an interface contains definitions for a group of related functionalities that a class or a struct can implement. By using interfaces, you can, for example, include behavior from multiple sources in a class. That capability is important in C# because the language doesn't support multiple inheritance of classes. In addition, you must use an interface if you want to simulate inheritance for structs because they can't actually inherit from any other struct or class. We'll get onto structs in a future video, so don't worry too much about that just now. You can define an interface by using the interface keyword. Any class or struct that implements the I-equatable generics T interface must contain a definition for an equals method that matches the signature that the interface specifies. As a result, you cannot count on a class that implements I-equatable generics to contain an equals method with which an instance of the class can determine whether it's equal to another instance of the same class. The interface defines only this signature. In that way, an interface in C# is similar to an abstract class in which all the methods are abstract. However, a class or struct can implement multiple interfaces, but a class can inherit only a single class, abstract or not. Therefore, by using interfaces, you can include behavior from multiple sources in a class. Interfaces can contain methods, properties, events, indexers, or any combination of these four member types. An interface cannot contain constants, fields, operators, instance constructors, finalizers, or types. Interface members are automatically public, and they cannot include any access modifiers. Members also can't be static. To implement an interface member, the corresponding member of the implementing class must be public, non-static, and have the same name and signature as the interface member. When a class or struct implements an interface, the class or struct must provide an implementation for all the members that the interface defines. The interface itself provides no functionality that a class or struct can inherit in the way that it can inherit base class functionality. However, if a base class implements an interface, any class that derives from the base class inherits that implementation. Properties or indexers of a class can define extra accessors for a property or indexer that's defined in an interface. We'll go over indexers in a future video, so don't worry too much about that just yet. The class that implements an interface can declare the same property with both a set and get accessor. However, if the property or indexer uses explicit implementation, the accessors must match. Interfaces can implement other interfaces. A class might include an interface multiple times through base classes that it inherits, or through interfaces that other interfaces implement. However, the class can provide an implementation of an interface only one time, and only if the class declares the interface as part of the definition of the class. For example, class name and the interface name. If the interface is inherited because you inherited a base class that implements the interface, the base class provides the implementation of the members of the interface. However, the derived class can re-implement the interface members instead of using the inherited implementation. A base class can also implement interface members by using virtual members. In that case, a derived class can change the interface behavior by overriding the virtual members. Interfaces summary. An interface has the following properties. An interface is like an abstract base class. Any class or struct that implements the interface must implement all its members. An interface cannot be instantiated directly. Its members are implemented by any class or struct that implements the interface. Interfaces can contain events, indexers, members, and properties. Interfaces contain no implementation of methods. A class or struct can implement multiple interfaces. A class can inherit a base class and also implement one or more interfaces. Okay, yes, a ton of information there, so let's go over this nice and slowly. Open up Unity and create a basic C# script. As always, make sure you give your script a different name than any other class in your project. I'll also be using Unity Spice again for all our Unity logouts to the console. So make sure that you download it by clicking on the card on your screen now and following the instructions. Okay, so an interface is defined like so. We put in the access modifier, which can be public, internal, and I believe you can have private if you want to put it inside of another class. Let's have a little look-see here. Private interface, IL. Yep, so you can have private interfaces, of course, as you would probably expect. So let's put in public. Then you define the interface keyword. Say define. I do, of course, mean type it out is, and then you would name your interface. Now, it's common practice in C# to name your interfaces starting with I, so that you know that it's an interface, and then proceed with whatever you want to call it. So I, and then interface, preceding it. Now, by all means, yes, you don't necessarily need to have this I in front of it. It could still be an interface like so. Now you can take it away, yes, if you want to, and there's nothing actually stopping you doing that, and it will still run as an actual interface. It just seems to be common practice in C# to have the I in front of it. So if you do see an I, you'll know, oh, okay, that's meant to be an interface implementation, although that's not necessarily correct. But still, whenever you see I, think interfaces in C# is. So okay, let's have a little look-see at the interface. And as the docs have said is, you cannot, let's call this enter, you cannot instantiate our interface. So if I went to do something like this, you'll see that we get an error, cannot create an instance of an interface, interface, of course, because it's an interface. Interfaces are probably, the best way I've heard them described this is that it's a contract that a class has to implement. So let's have this as class implementation, and we will inherit from our I interface. And as you can see, it doesn't really seem like it's doing anything now. And of course, I've spelled implementation wrong, like an absolute fool. Implementation, there we go. E as opposed to the I. And then we can, of course, instantiate our class from the interface inheritance. Yeah, implementing our interface. Now, of course, yes, it doesn't really look like we're doing anything. So now what I want to do instead is to create a public, public void. See, it's not even letting me type it is, it just knows that it's an error, method. Okay, and as we know, we cannot, it will come up with an error with this public in front of it, since the modifier public is not a valid for implement declaration, only new is valid. So you have to take that away. It is interesting to see that you can actually add in a new method. So I believe that if we inherited from another interface, interface previous, and then we had method here, and then had, of course, interface previous, you'd see that new would become valid since we want to implement a new method, and it would be on the interface interface as opposed to the interface previous. Yeah, a little bit confusing this. I must admit, I never have seen this new keyword used in any of the interfaces that I've created, but I suppose it is valid. I just would say it's probably bad practice to do it. But anyway, as you can see, we get an error coming up. Interface member method is not implemented. So now, much like our abstract classes, we need to implement the missing members. Now, unlike our abstract members, we don't have to have the virtual method, the virtual modifier, because this isn't overriding any method. It's just implementing the actual method. And yeah, that's pretty much it. We have to give our own unique behavior to this. Now you can kind of see why this might be a bit of an issue, because if we go and create a new class and call this implementation 2, why not? Because that's an equally as terrible name. And of course, if we didn't have the method here, we would still have to implement the contract. You'll see that we can't actually repeat the behavior between our actual interfaces. So there's no implementation here. So we've got to repeat our implementations here, which I must admit is I don't necessarily I want to say I don't necessarily like, but I suppose you could, I don't know. I mean, it seems it's great for polymorphism, no doubt about it. But if you're trying to inherit so that you can share behavior implementations of certain classes, it would probably be best to use an abstract class in that situation. But we'll press on with this here for the moment and leave it like so. Okay, so let's log out implementation and log out implementation 2. So as you can see, is nothing too crazy here, and this is where it can become really, really cool. So if I did iInterface instead of iImplementation, you'll see that we can now use the actual method using polymorphism. Also, if I was to actually put in another public method called just capital public, oops, you'd also see that we couldn't call out from inter since it is casted as the actual iInterface and therefore does not actually have that method. If I wanted to access that method, I'd have to explicitly say this is an implementation object, and then as you can see now we can get into that public instead. Right, so yeah, yes, using polymorphism, we can have another method down here. I'm going to call it method just so that we can get nice and confused. And let's have another interface. Let's actually pass an interface to this. Call this inter, and then call the inter method. Now, exactly like we did with our classes, yes, we can just pass in the actual implementation as an object, and it'll just treat it like an object that implements this interface. Simple as that is. So this method is going to work, and it should output implementation and implementation 2 to our logs. So go back into Unity, drag our script onto any game object in the scene whenever the game has finished compiling, and run the game, and you should hopefully see implementation and implementation to your logs. Super simple, Ace, especially since all of the background knowledge that we have done on polymorphism and inheritance, and also on the actual abstract classes. You can just see that this implements a contract that doesn't have any, I want to say doesn't have any sort of implementation on it. So you can also use this on, of course, properties. So let's have an int prop and get set. And as you can see, whenever I add it to the interface, then it will complain about it not being implemented in our other classes. Now this can be great, Ace, because not only can you have it implement one interface, you can of course have it implement another interface if you want to. So let's have another, and let's have this, I don't know, log, sure, why not? Log sounds like a pretty good method name to have, and then I can do another, put a comma down here, and there you go. Another, and another, and as you can see, we're getting an error because we're not implementing the missing members. Yes, so let's have that as log, and then of course add this one in here again and have that as log. Probably just best to put the log methods where they should belong, and let's go and change this to log. Now as you can see, oh no, this doesn't work anymore because it's only using iInterface. It's not using iAnother. We would have to, of course, change this variable of the inter to iAnother in order to use the actual log method. And this can be really, really useful, Ace, especially whenever you're using things like iComparable. I believe there's other ones like iList, and other ones that you can use. iEnumerable is a pretty good one, a fairly common one if you're trying to make your class like a collection, and that can be used in a for each loop. You'd probably use that there as well. So yeah, yes, I'm pretty sure that the actual docs have covered quite a lot of information here. I mean, I suppose I could sort of show you that, well, this can't be static for obvious reasons. And I suppose I could probably try and make this static, and we would get a problem saying that we haven't actually implemented the missing members, and therefore would come up with the iInterface dot just to make sure that we were doing the correct scope. And that's pretty much it, Ace. I mean, yeah, there's not a lot else I could say about that. I suppose the fact that this isn't public would be an interesting thing. So I wonder if I did actually use implementation 2, whether or not that would actually work. Let's do that there for argument's sake, just want to see if this would work. You know, as you can see, of course, it would work. You don't even need to have the public here, unless maybe it just instinctively just assumes that this is going to be here. No, modifier is not valid for explicit interface implementation. So I suppose with the explicit implementation here of the actual interface, it already assumes that it's going to be public case, and so therefore it's not necessary, it would appear. And yeah, that's that. So yeah, that's about as far as we're going to take interfaces. Yes, super simple, I know, for a fairly advanced concept, but because of all the work that we've done on polymorphism and our abstract classes, you can see exactly what's happening here. It can implement multiple interfaces, and of course can also inherit from a single class again. We of course can't have multiple inheritance, just like all the other ways that it works in C#. It will flag up an error, interface name expected. So there you go, Ace. Pretty straightforward, since we did have all that other background knowledge. So when would you use an abstract class over an interface? Well, whenever you want your derived classes to implement previous behavior from your base class, you would definitely use an abstract class instead of an interface. Interfaces will only be used whenever you want your actual class to inherit a specific contract, we'll say, or to implement the contract of that actual interface is. Ideally, you would have it implementing unique behavior for your classes. And yeah, I suppose you could probably create a class here that would implement shared behavior. And then from there, you could, of course, then go into here and have it so that you could just new up the shared behavior and then call, shared behavior, and then of course call some other method that would be consistent across both. If you wanted to do that, of course, then I would say, why not just implement an abstract class? And then you could argue, well, I'm inheriting from another class, so therefore I need to use the interface. And I would say you've probably got too many classes then in that case, yes. But of course, it's totally up to you. You're the coder after all. So I'm going to leave it there now, yes. And yeah, and that's it. Rate, comment, and subscribe, yes. I hope you're enjoying this series. I'm certainly enjoying getting back on the saddle with this. I really want to rattle through these C# videos in order for us to get onto our Unity project. You can email me at retrotk2@gmail.com with any questions you have about C#. Thank you for watching this, and I'll see you in the next video.